we have the same problem that a lot of farmers have had, and that's poor drainage in a couple of our tests. But this particular bean, this is the best looking beans we've got in a phosphorus rotation study here on the station. It's a Schillinger Group 5. The main thing I think that is of interest is this is the best looking bean where we have not applied lime. Here we're using reservoir water. The pH that we took in February, I think of this year when we took our samples. Some of them are in the high 4s, low 5s, so average about 5 pH. And we know from previous work that we've done with rice that the lower that pH is, the faster those soils go anaerobic. So the faster they lose oxygen. In comparison, this other bean that I picked out, that came from a soil, the same study just across the levee that we applied 1,000 pounds of lime on about 1.5 years ago. And just that higher pH, I think, has helped those beans be able to handle that poor drainage. Okay, so that's just kind of a sidelight of what we're going to talk about. You guys are probably sick of hearing me talk about potassium deficiency. But for soybean, potassium is the nutrient, just like rice, the nitrogen is for rice. Okay, if you've got to cut back in soybean fertilization, potassium is generally not the place to do it on these silt and sandy loam soils. At Pine Tree, we've got a study that we've had going for, this is the 10th year. And these are beans, that's a group 4 planted in late April. They're getting pretty close to being finished. But you don't have to go out to the plots to see this. It shows up from, as long as you drive up close enough to be able to see, around the other crops that are planted in that area, you can see this yellowing on top. In soil fertility, we teach that potassium deficiency symptoms appear on the lower leaves because potassium is mobile. So you say, well, if that's the case, those deficiency symptoms should be occurring on the lower parts of the plant. When these beans start setting seed, just like in cotton, where they start seeing, these short season, fast fruiting cultivars, the demand for K is very high whenever that reproductive system kicks in. So when these beans are trying to set seed, a lot of that K is being moved, and if it is short, it's going to come out of those top and middle leaves of the plant. So it's kind of going against some of the things that we teach in soil fertility. So potassium deficiency very easily can occur in these upper leaves, but generally when it does occur on those upper leaves, again, that seed is starting to set, and a lot of that potassium is having to be moved from those top and middle leaves to that seed. So these are beans that again have not had any potassium for 10 years, and this plot is cropped in a rice soybean rotation. This is the 40. This is these beans are from an area that has received 40 units of potash every year for the past 10 years. They are not showing in general the symptoms, the same type of symptoms that the no potash beans are showing, but it's probably hard to see it, just me holding these plants up, but when you're in the field, they just don't quite look as good as the other beans that these plants were taken from a plot that has received 160, the highest rate that we have in the test. Probably a little bit overboard, but certainly, we wanted to go overboard with our fertilization just to make sure to see where maximum yield was being met. And we were also looking at the rate at which soil potassium on your soil test accumulated. The interesting thing about this particular study from the soil standpoint is that the soil test K in the soil that has not received any potash for 10 years has fluctuated between, it started at about 80 parts per million, it's dropped down to about 65 in some years, it's been as high as 100 in some years. But it really, when you look at the long-term trend, has hovered right around that 80 parts per million. So, where you're not supplying adequate potash, your soil test may not be continuing to decline in some soils. It may be staying about where it's at because it's already at the point that it's kind of reached an equilibrium, okay? The other side of that coin is where we have applied the high rates, 120 to 160 units of potash per year. The soil test has not climbed as high as what we would like. So we started looking at another test that extracts some what we would call non-exchangeable or fixed K. And a lot of the potash that we're applying to these soils is going into that non-exchangeable or fixed K pool. And you say, well, that's not necessarily good because that doesn't sound like it's available. Well, it's kind of like a savings account. That potassium comes out slowly, and the more you've got in that non-exchangeable pool, the more it can supply that exchangeable pool in a year where, say, you decide you need to cut back from an economic standpoint because potash is $800 an acre, or $800 a ton. So there are some good things about that. The main thing on soil testing for potash that I'd recommend is that you do a good job sampling your fields at about the same time every year. If you're sampling every other year or every third year, sample it behind the same crop. If you're in like a rice soybean rotation, sample it behind rice. Pay attention to the depth at which you're sampling. Our recommendations for beans and rice are 4 inches. And keep track of that over time. Go into Excel or some other program and track that so that you can kind of watch those trends across time, because occasionally we do have a year pop up where the soil test K is either real low, like in a dry year, or in a wet year it may increase some. And so we can get kind of like an odd reading in some years. I had several calls about that this spring, and again, the best way to fight that is to go back and look at how the soil test has behaved before.